morning. Today, long division, lesson number 7. Purpose of this is to make sure that you know your math facts. And that's really the value. If you can do this stuff really fast, that means you know your math facts. If you struggle with this, it's because you don't know your math facts. So let's start with some basic long division ideas. Let's say you have a problem like 31 divided by 8. First one is to remind you that's the same as 31 over 8, or it can be written as 8 goes into 31. I remember that because I think of this as like a tree that falls to the right. And it falls to the right, the 8 is like this, and the 31 is like this. So it kind of looks like that one. That's how I remember it, so that's what we're going to do. So as you can tell, if you know your math facts, 8 times what is 31? The answer is nothing. 8 times nothing is 31. So to do this and get the decimal answer for it, what we do is we say 8 times what gives me something close to 31, but not over it. So in this case, 8 times 3, and I put the 3 right above the 1. I think of this as the tens place in the singles or the ones place, and then there's decimals, and then there's other things. But 8 times 3 is 24. And I draw a line, and I do a subtraction problem, and I end up with 7. And again, I know it's going to be not 4 because 4 is too big. It's going to be bigger than 3, so it's going to be 3 point something. So then I just add a 0 here. So I say 8 times what is 70? Well, 8 times nothing is 70, but 8 times 8 is 64. Again, you're going off your math facts. And then I subtract. 70 minus 64 is 6. Add a 0. So then I say 8 times what is 60? Well, 8 times 7 is 56, which is close as I'm going to get. And I end up with 4 left over. And then I'd say, well, 8 times what is 40? Well, 8 times 5 is 40. When I get to the point where it is 0, I am done. The answer is 31 divided by 8 is 3.875. That's how you do long division with a simple fraction like this. Well, now let's look at what if it's not quite so simple. Again, the process is similar, but it takes a little bit more work. So I'm going to give you one that's a little bit harder. I'm going to say, what if you have 0.004415 divided by 0.032. That's a ridiculous number, something you would see in a science problem, and you would just take a calculator too. But we're going to do this so that we can practice our math facts and make sure that you can do them quickly. Well, again, I'm going to write this as a long division problem by putting this on the outside and the other one on the inside. So the first step is remember which one goes on the outside, which one goes on the inside. I always remember by doing it as a tree that falls over. Okay, now I get to here, and I don't want to deal with decimals out here. That's first thing, that's when they're ugly like this. So I'm going to change this by moving it 3 to the right. Okay, what I'm essentially doing is I'm multiplying this times 1,000, and then it becomes tens, hundreds, thousands. It becomes 32. And I multiply this one times 1,000, and it becomes 4.4. So it becomes 32 goes into 4.415, a much more reasonable number. And that's why I do it that way. So I'm not changing it. Again, we're thinking of this as a fraction. It's 0.0004415 over 0.032. If I just multiply this times 1,000 over 1,000, I don't change anything. Multiply the tops by 1,000, bottom by 1,000. That's how I can get rid of those decimals. Okay, now I say 32 goes into 4 0 times. It doesn't, it's too small. But 32 goes into 44 once. So it becomes 3.2. Draw my line, I get 5, and most math places will show it like this. I like to put the zeros in there so I can do subtraction. 5 minus 0 is 5, 1 minus 0 is 1, 4 minus 0 is 2, and then I get 1.215. Okay, so now I'm going to look at 32 goes into 121 how many times? Well, 32 times 4 is 128. 32 times 3 is 96. Okay, again, looking at 121, 96. So I'm kind of in my head, I'm looking at this number. 96 goes there. That's why I line it up like that, and I don't put the 9 over here or anything. Okay, and I put a 0 there, and I get 5. Oh, there's times 3. And so 11 minus 6 is 5. 12 minus 9. I had to carry 1, so 11 minus 9 is 2. Again, there's my decimal. So then I say 32 goes into 255. How many times? Well, 3 times 8 is 24. So let's try that one. 32 times 8. 8 times 2 is 16. And carry the 1. 3 times 8 is 24. 25. That's too big. 256. It's close. So I'm going to have to go times 7. So let's look at that. So 32 times 7. 7 times 2 is 14. 7 is 224. So this one becomes, put a 7 there, and I get 224. The remainder, I get 1. 5 minus 31. So now I've got 32 goes into 31. How many times? And I can keep going here. And it would probably go on forever. So if I were to ask myself, it's very common, you would say, what's the answer to this to 2 decimal places? So in this case, I'm not actually looking for the total answer. I'm looking for the answer rounded to 2 decimal places. Well, there's one, this is called 1 decimal place. This is 2 decimal places. Well, as we remember from last time, this becomes 0.14 because this number is 5 or bigger. That's the answer, 0.14. You'll see this on page 29, and this is an example. So if you missed any of that, look at the example on page 29. All right, that's it for lesson number 7, a review of long division. Yeah, I know it seems painful, but it forces you to know your arithmetic facts. Okay, let's look at lesson number 8. 8 is fairly simple. This is going to be dealing multiplying by tens or 100 or 1,000. What do you do? Well, this is, so for example, I have a number 4162, and I want to multiply it times 1,000. Count the zeros. There's 1, 2, 3. Add 3 zeros to this. 4, 1, 6, 2, 0, 0, 0. And then I go ahead and put my commas where they need to go. That's the answer. If I multiplied by 10, I would add 1 0. If I multiplied by 100, I'd add 2 0. If it's a decimal, like let's say 3.615, and I want to multiply times 100, how many zeros? 1, 2. I'm going to move the decimal, instead of adding zeros, I'm going to move the decimals to the right, 2361.5. And that's the answer. So if there's a decimal, I multiply it I just move the decimal by how many zeros there are. And that's all this lesson is. Now, what about if you divide by stuff? Well, let's say I have a number like 305.618, and I want to divide it by 1,000. Okay, count the zeros. 1, 2, 3. In this case, because I'm dividing it, I'm moving it left. 1, 2, 3. So I get 0.305618. And that's the answer. Divided by, same thing, you count the zeros, but you move it that way. Multiplying, you move it the other way. And that's how you do it. That's pretty much what this lesson is. So, congratulations. You've now finished lesson number 8. Okay, next one is going to be lesson 9. All right, lesson 9 is going to be the new one. Lessons 7 and 8 are part of the next test. But lesson 9 talks about line and some basic vocabulary and a little bit of shapes. So let's look at some things. Something that is at a 90-degree angle is called a right angle. We can show that by making a little box there. So it either says 90 degrees or it has a box on the corner that looks like a little square. That's called a right angle. Something that's less than 90 degrees, this part, is called an acute angle. Everybody remembers it by going, oh, it's so small, it's so cute, it's a cute angle. Yeah. And anything bigger than 90 degrees, like that one, is called an obtuse angle. You might have a hard time remembering that one. Obtuse. I don't know, you have to figure out what that means. And then, what if it's exactly 180 degrees? It's not really an angle, but it is an angle. It's a 180-degree angle. We call that one as a special one. We call that a straight, S-T-R-A-I-G-H-T, angle. Okay? And those are different ways to say it. And that's it. What if it's more than 180? Well, then we look at this one. We don't look at the big angle typically. All right, so that's the types of angles there are. Right angles, acute angles, obtuse angles, and straight angles. All right, there's also a lesson on this, on lesson number 9, talking about perimeter. Perimeter is basically walking around, or the distance around. So they give you some examples. For example, if you have a rectangle that's 3 on this side and it's 4 on this side, and you say, what's the perimeter? Well, because it's a rectangle, this is going to be 3 and this is also going to be 4. And you just pick a spot, and I'll pick there, and I walk. I go 4 plus 3 is 7, plus 4 is 11, plus 3 is 14. So the perimeter is 14. And if they say this is centimeters, and this is centimeters, and this is centimeters, and this is centimeters, then the answer is going to be in centimeters. So whatever unit they're using, whether it's centimeters, miles, inches, whatever, you use it. Sometimes you get ones that are a little bit more complicated, that they're like this. And you know that, let's say this one's 8, this one's 4, this one's 6, this one is 14, this one is also 6, and this one's 2. And they say, what's the perimeter? Well, there's a couple you don't know. You don't know this one, and you don't know this one. Well, I know that if this is 6, you have to logic your way through it. If this is 6 and this is 6, that means, and these are right angles, that means if this is 8, this one's got to be 8. I also know if this is 14, that 4 plus this is 14. So 4 plus 2 is 6. So this has to be 8, because 4 plus 8 is 12, plus 2 is 14. So now if I want to know the perimeter, I can say, okay, 4 plus 6 is 10, plus 8 is 18, plus 6 is 24, plus 2 is 26, plus 8 is 34, plus 14 is 44, 48, plus 8 more is 56. And that's the answer. So you have to kind of logic your way to find the missing pieces and then just work it. And that's it for lesson number 9. Have a great day, and I will see you later.